All right, 10.2, vectors in the plane. The essential question is, what's the vector, Victor? What movie is that from for a piece of candy?
Despicable Me.
Is it really?
Yes.
No, it's not.
What's the vector? Is that?
His name's
Well, the name's Vector. I thought of that.
That's we did.
Okay, it goes. What's the vector, Victor? We've got clearance. Roger.
Airplane.
Airplane.
Oh, I've actually seen that movie.
The three pilots are named Roger, Victor, and Clarence. What's the vector, Victor? We've got clearance. Roger. Okay, good thing I started recording 41. Two vectors in a plane, so I don't know if there's much. Yes, there is a little bit of calculus in this section, not a whole lot. Most of it is like physics / pre-calc stuff. So vector represents a force or an acceleration or momentum. It's a graphical representation of something that has a magnitude and a direction. So if you have U here, its component form is 3, 2. You know it's a vector because it's got the up here. Right, there it is. It's got alligators, not parentheses. So that means we have 3 in the horizontal component, 2 in the vertical component, and there's U. Notice that V is 3, 2, but it has a different location. So their location or position. So vectors do not have position. You can, as long as you keep the same orientation, you can slide them around. And the length of them represents the magnitude. So if U was twice as long, it would be twice as powerful of a force. So if it represented the wind speed, it would be square root of 13 miles per hour. If it was twice as long, it would be twice as powerful wind speed.
Always square root of 13?
Well, just because it's Pythagorean theorem, 3 squared plus 2 squared equals
Oh, okay.
for this one. Let's see. So find the component form and magnitude of the vector with an initial. Okay, so initial point and terminal point. The initial point is negative 3, 6 right here. The terminal point is 2, 1. So that's where the dot is. And that's where the arrow is because it's going in that direction. This is called the head, or I always learned it as the tip, and this is the tail. The book calls it the head and the tail. So we're going to represent that vector in component form. Well, you just need to know how far over, how far down, so it's 5, negative 5. And the magnitude using a special right triangle, 5, square root of, or 5, 5, square root of 2, so it's 5 square root of 2. Component form of a vector of length 7 that makes an angle of 130 degrees with the positive x-axis. So there's my 130 degrees. So that means I have a 50-degree reference angle. The length is 7, so then you use trig, SOHCAHTOA style, and figure out what this is and what that is. This is the horizontal, it's negative because it's going left. There's your vertical, which is positive because it's going up. So far, so good? Remember this stuff? Physics people?
Yeah.
You do physics? Who else has done physics? Or is it?
We don't do vectors like
I think
that.
we
though.
started it very briefly at the end of, or the beginning of the year last year.
Yeah, we
Like maybe half a unit.
In
I
physics?
do physics too, and that's it.
touch it.
And do you, so you said you don't do vectors that way. Do you do linear combination like I's and J's, or what do you do?
We don't do.
You don't do much vectors, or you haven't yet?
We do like vectors. We just don't represent them as like vectors. I guess.
Oh, like graphically?
Yeah.
I see. Okay. All right. So just some, I guess, arithmetic. So there's my u, there's my v, then 3u minus 2v. As it's just how you intuitively would think. You distribute the 3, distribute the negative 2, and then just combine the horizontal and the vertical, as you might expect. U dot V, that's called a dot product. It's not times, it's a dot product, and you do one vector dot another vector, and you get a scalar result. Scalar is just a magnitude. It's how big something is, but does not have a direction. So U dot V is just 4 times -1 plus -2 times 6. Okay, the x, multiply those, and combine them. And that's -16. So you'll use a dot product for sure in some formula, like finding projecting a one vector onto another vector. You'll use that within formulas, but there isn't a great representation of what a dot product represents. I use the word represents.
Like for fun?
Well, it's a skill that you'll use within something. Like U dot V, if you get 0, and that's your third word for perpendicular. You've got perpendicular, then we learned normal, now we're using orthogonal. And the only thing different with orthogonal than perpendicular is U dot V equals 0. A 0 vector is considered orthogonal also. But it's just kind of a technical. Think of it as orthogonal or perpendicular. How's that for a confusing answer? Okay, so you don't really need to know what it means right now. But you'll have to apply it within a formula at some point.
So U dot V, if you get 0, means the two different vectors are perpendicular,
It means that they're orthogonal.
which means they're perpendicular. Just accept it, Lily.
It means that they be perpendicular, yes.
They
I
would
think,
be
if
or
I'm
they-
remembering right. What's that?
They would be or they are?
Well, let's try one. So I'll do, let's do this vector, I'll call it,
See it?
well, open your eyes. 2, 2. And then I'm going to say this vector is -2, 2. True?
Yes.
Okay, so let's do, that's U and that's V. Figure out what U dot V is. Alex just was making some noise.
Thing you're doing?
Oh, you want me to present?
Yeah.
Do you realize that how far into, we're 7 minutes in and I've been following the notes all along. It's a good idea to present.
There you go, Lily.
What do you get?
0.
Okay, so that means that they're orthogonal, which is kind of perpendicular. But if you did this, what if the W vector was 0, 0? And why don't you do V dot W? You also get 0, but it's just kind of a weird technicality that it's orthogonal, but can you really consider that right there perpendicular to this?
Does it even exist?
No, it's just, it would just be a point, yeah.
Okay.
Okay, but they're still considered orthogonal because the dot product is 0.
Okay.
Yeah,
Well, like,
That's the only
it would be
difference.
perpendicular. Like, it's a point.
I know. Well, that's the difference. That's why they aren't considered perpendicular. They're called orthogonal. It's a little bit different than perpendicular.
Okay.
Good question. Find a unit vector in the same direction as -4, 7. Focus. Okay, so the long way, kind of using our geometry background, unit vector, unit anything means 1. So unit circle has a radius of 1. Unit vector has a magnitude of 1. So we're looking for a vector like this, but with a magnitude of 1. So we could set up similar triangles because they're the same shape, just different sizes, and do proportions, cross multiply, and we get our answer. That'll always work. So if you forget what I'm about to tell you, you can always draw two similar triangles. Just make the magnitude of the unit vector 1, find your x and y, and those are your horizontal and vertical components. What's the shortcut? Looking at this answer, looking at this right here, your unit vector
You just put it over the.
magnitude. Yep. So the shortcut would be to take this over the magnitude, that over the magnitude, and that's your unit vectors. Because the magnitude is the hypotenuse. Aeroplane problem. Yeah, these you did in pre-calc.
Yeah.
They were some of the tougher problems you had all year.
It was like unit 1.2. That was dumb.
What was dumb?
It was in unit like 1.2 or like.
You remember that?
Yeah, it was really weird.
Okay, so an airplane travels at 900 miles per hour heading in still air, 15 degrees north of east. Okay, so north of east means it's north of east is right down here. That's our 15-degree angle. Wind is blowing at 40 miles an hour and is traveling 20 degrees east of north. So there's north.
Hold up.
And east of
I'm
north.
so confused.
So
Is it north up?
north is up. So if it was going straight,
North.
thank you, Larry. So
But like.
if it's going up and it's 20 degrees east of north, it's not going straight up, it's going a little to the right, a little to the east. And that's this guy right here, that's that vector. So what I did is I drew my original vector, which is the 900 mile per hour. That's this one right here. And then I added them geometrically using the tip to tail method. So if I have this as my original and then I've got another contributing force right here, this is what's actually going to happen to the plane, this resultant vector. So find the resultant velocity and direction. So this vector plus that vector equals that vector. You just start here and you connect wherever you end up. So graphically, that's how you can do it. That's only one way. There's two ways that I'm going to show you how to do it.
I gotta get a hoodie like that. What? I gotta get a hoodie.
Okay, off the wall.
Oh.
Oh, that was difficult, but catchable. We'll see you again tomorrow.
Thank you.
Yep. Okay, so we want to find how long that is, and that's how fast it's traveling. And we also need to find like this angle right here, because that will be its direction. So using our geometry, I drew an auxiliary line straight up, that's my north-south. I drew another east-west one right here, because I need to, let's see, alternate interior angles. Says that that's going to be 15 degrees. I've got a 90-degree angle right here, and this 20 degrees is what was given, 20 degrees north. So these all add up to be 125 degrees. That's a 125. Looks like a 65, 125. Okay, so this is 40, that's 900. So that's enough information to find the resultant magnitude using the law of cosines.
Are we gonna have to memorize that?
Yes. Law of cosines, well, if you wanted to do it this way. I'm going to show you a different way of doing it. So if we do it geometrically, we would want to find this. Law of cosines is used when you have a side angle side or a side side side. Those are the two times you use law of cosines. You might have only done law of cosines in pre-calc, because I don't even know that they get to loss cosines and loss sine, maybe loss sines in geometry.
We
did not do that.
We did not do any cosine or sine stuff.
Yeah, I think that they deem that as non-essential now. So that's all right.
Science and cathedral, but I don't.
Okay. So if you have a side angle side scenario, you can find the opposite side from the angle by just saying that's x. So it'll be x squared equals this squared plus that squared minus 2 times this times that times the cosine of that angle. I'll say that again. So this squared equals this squared plus that squared minus 2 times that times this times the cosine of the angle. So it looks a lot like, what's that look like right there? Pythagorean theorem. So what do you think is going to happen when you have a 90-degree angle?
Oh.
All of this stuff is going to disappear. Because what's the cosine of 90 degrees? It's 0. So this is like, the Pythagorean theorem is actually a special case of the law of cosines. Okay, so we have how fast the plane is actually traveling. The engine thinks it's going 900 miles an hour because that's how much power it's using, but it's getting a little bit of help from the wind. So the speedometer actually would read 923.5 miles per hour. So we're halfway done. We now need to know its direction. So we need to know this angle here. We know that's 15. So if we find that angle right there, just add it to 15 and we have our direction, which is found using the law of sines. Law of sines, I should be ready. So law of cosines, I think this is an extra note sheet. Are we missing somebody? No? Law of cosines is side angle side and side side side. Law of sines is like everything else. Angle, angle, side, angle, side, angle. I guess you could do side, side, angle, or ASS. We don't talk about that in here. But the ASS is a bad word, and it produces bad results sometimes because it actually gives you sometimes one answer and sometimes two answers. And that's based on the math. How's that for, like if you had, like this was your triangle. And you know that this side, and you know this side, and you know this angle right here. This side right here produces a triangle as it is. But if you pivot that and put it right there, it's still the same side, same angle, but it would produce a different triangle. So that's a really tricky one that we're not really going to talk about right now. We'll assume you mastered that in geometry. Okay, so side angle side is the sine of an angle over the opposite side equals the sine of another angle over its opposite side, which is also equal to the sine of the third angle over its opposite side. So we have enough information to find theta here because we know the sine of 125 over that equals the sine of theta over that. And then you can cross multiply 40 times the sine of 125 divided by that. And then you get sine of an angle equals some number. You have to do the inverse sine, and we get 2.03. You'll get sine theta equals a number, do inverse sine, you get 2. Okay, so that's how big this angle is, 2.03.
Do we have to change our calculators? Yes.
Yeah, now you might be getting into trouble with, if you're going to be degrees, you have to be in degrees, yeah. So it looks like it's 17.03 degrees north of east.
Wait, so what's the difference between east of north and north of east? Like they're both going.
Good question. So the first one is where you start. Oh, so north of east. Of east means you started at east and you did 17 degrees north of that. East of north, meaning you're going north, but it's actually 20 degrees east of it.
So you could also say you're going 7 70 degrees north of east?
Exactly, yes.
Okay.
And if you didn't hear that, she said you could also say that you're going 70 degrees north of east. I don't know if it has to be like, I've seen some books that only use north and south as their headings. You're never going to go north of east. It's always east or west of north or east or west of south. This book seems to go back and forth, and maybe it's just because if it's under 45 degrees, they choose the closer axis, I guess. I don't know. All right, any other questions on 10.2? Oh, I should show you the other way of doing this. I think it's easier.
Is there a way to do it like the related rates way, like differentiate?
I think there is. Well,
Where it's set like values for these, but
I don't know. I'd have to think about it. I know that there's some problems like that you could do it that way. Okay, because I think for this problem, we still would have to use quite a bit of geometry to find the givens, yeah. That'd be interesting, though. Okay, so a different way of doing it. We're just going to use component form. So we've got one vector. It's going 900 miles an hour, 15 degrees east of north. So if I wanted to find its components, 15 north, north of, did I say east of north? North of east. Okay, so here's my vector. It's 900, and this is 15 degrees. So we can find its components by just finding x and y. So sine of y equals, or sine of 15 equals y over 900. So our y is 900 sine 15. Our x would be 900 cosine 15. Okay, so the airplane vector is 900 cosine 15, comma, 900 sine of 15. We've got one vector down. The other vector, the only other vector in this problem, it says wind is blowing at 40 degrees or 40 miles per hour, traveling 20 degrees east of north. Okay, so we've got this vector. This is 20 degrees. So that means this is 70 degrees. And the hypotenuse is 40. So the x would be 40 cosine of 70, and our y would be 40 sine of 70. Just using like trig. Oh, I don't know why I did it that way. I didn't do that right. I'll do it down here. So it's 40 cosine 70, comma, 40 sine 70. We have two different vectors. We can just add them and we get our resultant vector. So that better go mode degrees. This calculator hasn't been in degrees in a long time. So 900 cosine 15 plus 40 cosine 70. So our resultant vector, I will go blue, is 883.01, comma, 270.52. So there's my resultant vector. So if I want to know its magnitude, I could just do the Pythagorean theorem. If I wanted to know, okay, so this is my resultant vector, because I know it's 883.01 and 270.5, whatever. You can find the hypotenuse, and it's going to be 923.5, because that's what we got before. 923.5 And you can find theta, and that's going to be 17.03, because that's our angle. You can find theta by doing an inverse tangent of 270.5 over 883.01, and that'll get you your 17.03. So two ways of doing the same problem. If you don't want to do a lot of sines, a lot of cosines, just create both component forms of the vectors given. If there's three, just stack them up, add them, and then do the Pythagorean theorem to find the magnitude and inverse tangent of the y over the x to find its direction. We like that better or worse? Or both kind of, you have to figure it out.
We do this one in physics more.
What do you say, Claire?
We do this in physics more, like that.
That version? Okay. Any other questions?